In this tutorial, we are going to talk about arithmetic and geometric progressions. Let's start with arithmetic progression. By definition, an arithmetic progression, or just AP for short, is a sequence in which the difference between any two consecutive terms is a constant, which is called the common difference and denoted by lowercase letter d. Now, the general form of any AP is A plus D, A plus 2D, and so on. The three dots at the end indicates that this sequence goes on forever. The first term, which is A, is also called the initial term, and letter D stands for the common difference of the AP. Now, inherited attribute D equals T2 minus T1, T3 minus T2, and so on. Basically, all that means is just difference between any two consecutive terms. Now, for instance, say we have the AP 2, 5, 8, 11, and so on. So the first term or initial term A equals 2. Now the difference is 3. So to get 5 from 2, you add 3 to the previous term. Now, how to get 8 from 5? We need to add also 3. So for the next term, the same rule. 8 plus 3 gives you 11, and so on. And again, if you find the difference between any two consecutive terms, let's say 5 and 2, it's going to be 3. If we pick another two terms, let's say 11 and 8, the difference would be the same. So 11 and 5, again, it's 3. Now, let's move to geometric progressions. By definition, a geometric progression, or GP for short, is a sequence obtained by multiplying the preceding term by a constant, which is called the common ratio and indicated by small letter r. Now, the general form of the GP is AR, so A times R, AR squared, and so on. Again, it goes on forever. Now, this letter A means the first term, or again the initial term of the GP, and R is the common ratio. Inherited attribute is gonna be just the ratio between any two consecutive terms. So all you want to do to get this ratio, you want to take, let's say, T2 and divide it by the preceding term, T1. So it's going to be the same number, T3 over T2, and so on. For example, say we have GP 2, 6, 18, 54. So your first term, A, is 2. Your ratio is going to be 3. Okay, how to get it? So we take 6 divided by 2 by the previous term. It's going to be the same number as we take 18 and divided by 6. You could pick another two consecutive terms, and the ratio is gonna be the same number. This is 3. So that's the general idea, the general gist of GP. Now there are some problems to carry out. Fill out the gaps. Answer key. Now, let's talk about formulas that come up when we do AP and GP. For arithmetic progression AP, the nth term can be found by the following formula. AN, which stands for the nth term, is A plus n minus 1 times D. Again, where A is the initial term, D is the difference. And the first formula, actually, we already discussed before. It's the general form, A plus D, and so on for the AP. Now, the sum of the first n terms could be found by two different formulas. So the first one, Sn, which stands for the sum of first n terms, is n over 2 times 2a plus n minus 1 times d. And the second one, n over 2 times a plus l, where a is the first term and L stands for the last term actually. So the second formula is applied when you already know the last term. So it's actually for finite mostly sequences. The first formula can be used for any sequences, for any AP. So again, the second one, when you are given the first term and the last term. So it's commonly used for this case. But again, it all depends on the situation, on the problem, and on what you have to find. All right, let's move to geometric sequences, geometric progressions. So the general form is a times r squared, and so on. The formula to find the nth term is an equals a times r to the power of n minus 1. And here are a couple of formulas for some of the first n terms. The first one, Sn equals a times 1 minus r to the nth power over 1 minus r, where r is less the ratio than 1. The second formula is very similar to the first one, and it applies when r, your ratio, is greater than 1, so the difference is only 1 and r to the n, they switch, the order is switched. And the last one is sum to infinity. So S symbol infinity is a over 1 minus r, where absolute value of r is less than 1. When absolute value of r is greater than 1, then GP has no sum, so we cannot find sum. Alright, work out the following problems. More problems?